Hello student, I am Sarama Malik, Assistant Professor of Gargi Memorial Institute of Technology. In my previous lecture, I discussed about Euler graph and today I discuss about Hamiltonian graph. First you have to know that what is Hamiltonian circuit. Hamiltonian circuit is circuit in a connected graph capital G is said to be Hamiltonian Hamiltonian circuit if it includes every vertex of G exactly once. Okay, so in a graph, if every vertex of the graph is includes only one times, then that circuit is called Hamiltonian circuit. Okay, so in this figure, this is a graph. Say this is a graph G, and here there are 3 points A, B, C, and 4 edges. Okay, so in this figure, the circuit capital A small a, capital B small b, capital C small c, capital A, this form a Hamiltonian circuit. Okay, there are some properties. Number 1, a disconnected graph cannot have Hamiltonian circuit. Number 2, a Hamiltonian circuit in a graph of n vertices consist of exactly n number of edges. And number 3 is every connected graph may not have a Hamiltonian circuit. For example, this figure. Say there are 6 vertices. Okay, V1 to V6, and the edges are, this is E1, this is E2, this is E3, so it is E4, E5, E6, and it is E7. Okay, so in this figure we cannot draw the Hamiltonian circuit. Okay, so in figure 2 has no Hamiltonian circuit. If you start from say V1, you can't go through can't come back to V1 by covering all the vertices. Say V1, V2, V3, V5, V4. Then again you come to V3, which is repeated here. That is not the condition of Hamiltonian circuit, and because Hamiltonian circuit includes the all the vertex exactly one times. Okay, so this will not form the Hamiltonian circuit. Now Hamiltonian path. Hamiltonian path. A path in a graph capital G is called Hamiltonian path if it contains every vertex of G. So in figure 1, the path is CC, capital A, capital B is a Hamiltonian path. Hamiltonian path. Next, there is also some properties. Number 1 is if any one edge is removed from a Hamiltonian circuit, then a open Hamiltonian path is obtained. Okay, and number 2 is every graph having a Hamiltonian circuit has also a Hamiltonian path. Okay, and number 3 is a graph may have a Hamiltonian path but no Hamiltonian circuit. For example, say in this figure, here In this figure, in figure 3, y, capital Y, X, capital X, Z, capital Z, small w, capital W is a Hamiltonian path. But there is no Hamiltonian circuit. Okay. And property number 4 is the length of a open Hamiltonian path in a connected graph of n vertices is n minus 1. And number 5 is a Hamiltonian circuit or path cannot include a self loop or parallel edges. Because in a Hamiltonian circuit, no edge repeated. So, to find the Hamiltonian circuit, first we remove all the loops and parallel edges. Okay. So now Hamiltonian graph. What is Hamiltonian graph? A graph is called Hamiltonian if it has a Hamiltonian circuit. Okay, that means figure 1 is a Hamiltonian graph. Okay, now we discuss about isomorphic graph. Two graphs, say capital G, which vertex set V and edge set E, and capital G dashed with vertex set V dashed and edge set E dashed. are said to be isomorphic if there exists an injective mapping F where V tends to V dashed such that there is an edge between FV1 and FV2 in G dashed. If and only if there is an edge between V1 and V2 in G. That is two graphs G and G dashed are isomorphic if we get one and only one vertex in G dashed corresponding to each vertex of G. Okay, that means number of vertex in G and G dashed both are same. And number 2 is we get one and only one edge in G dashed corresponding to each edge of G. That means number of edge in G and G dashed also same. And number 3 is the incidence relationship between vertex and edge is preserved. Okay, so these are the three conditions of isomorphic graph. And if two graphs are non-isomorphic, then we say that they are distinct. Okay, so in our next lecture we discuss about the isomorphic graphs.